These images changed us. They gave us proof of worlds we could not touch. They showed us violence frozen in nebulae. They revealed storms older than civilizations. They captured light that traveled for billions of years to reach a sensor the size of your palm. You will see Earth as a fragile marble suspended in nothing. You will witness the birth of stars and the death of giants. You will look into the face of a black hole. These are not decorations, they are evidence. They are the receipts of our exploration. They forced us to recalculate our importance. They gave us humility and ambition in equal measure. This is the visual archive of our cosmic education. December 24, 1968. 3 men orbited the moon. Frank Borman turned the camera toward home. The photograph stopped the world. For the first time, you could see Earth as an object, a sphere, alone, fragile. Before this moment, Earth was the ground beneath your feet. It was infinite. It was the center. This image destroyed that illusion. You saw oceans and clouds and continents wrapped in a thin film of atmosphere. You saw how small we are, how isolated. Environmentalism was born from this perspective. You cannot see borders from space. You cannot see nations. You see one world, one home. This image gave us the overview effect, the cognitive shift that astronauts describe when they realize Earth is all we have. It is our only refuge in a hostile universe. February 14, 1990. Voyager 1 was 3.7 billion miles from home. Carl Sagan asked NASA to turn the camera around one final time. The result was humbling. Earth occupied less than a single pixel, a pale blue dot caught in a scatter of sunlight. Sagan wrote that everyone you love, everyone you know, every human who ever existed lived on that dot. Every war, every triumph, every empire and philosophy happened there, on a mote of dust suspended in the sunbeam. This image crushed human arrogance. It showed us our cosmic insignificance. Yet Sagan also saw beauty in it. That tiny world is where we make our stand. It is the only home we have ever known. The photograph became a manifesto for unity and planetary stewardship. It reminded us that in the vastness of space, we are all crew members on the same fragile ship. 7,000 light-years away, stars are being born. The pillars of creation are columns of cold hydrogen gas and dust in the Eagle Nebula. Each pillar spans several light-years in height. They are stellar nurseries. Inside these dense clouds, gravity pulls matter together. Pressure builds, temperature rises. Eventually, nuclear fusion ignites. A star is born. The Hubble Space Telescope captured this scene in 1995. The image became an icon. In 2022, the James Webb Space Telescope revisited the pillars using infrared vision. It saw through the dust. It revealed dozens of young stars hidden inside. The pillars are not permanent. Radiation from nearby massive stars is slowly eroding them. In a few million years, they will vanish. But for now, they stand as monuments to creation itself. They prove that the universe is not static. It is violent, generative, and alive with transformation. In 2003, astronomers pointed the Hubble Space Telescope at a patch of empty sky. The region was smaller than a grain of sand held at arm's length. They exposed the sensor for 11 days. The result was staggering. The image revealed 10,000 galaxies. Each galaxy contains billions of stars. Each star might host planets. You were looking back in time. Light from the most distant galaxies had traveled for over 13 billion years. You were seeing them as they appeared when the universe was young. 1. The ultra-deep field proved that the cosmos is unimaginably vast and ancient. It showed that galaxies are everywhere. There is no empty space. Every dark patch of sky is teeming with distant worlds. The image forced cosmologists to recalculate the number of galaxies in the observable universe. Current estimates exceed 2 trillion. This photograph is a humbling census of cosmic abundance. April 10, 2019. Scientists unveiled the first photograph of a black hole. It took 8 radio telescopes across 4 continents working in unison. They created a virtual telescope the size of Earth, the Chickenator. The target was M87 star, a supermassive black hole 55 million light-years away. Its mass equals 6.5 billion suns. The image showed exactly what Einstein's equations predicted. A century earlier, a dark circle surrounded by a ring of glowing gas. The circle is the event horizon, the point of no return. Beyond that boundary, not even light can escape. The glow comes from matter accelerating to near light speed before falling in. It reaches millions of degrees. 1. The asymmetry in brightness is caused by relativistic beaming, where matter moving toward us appears brighter. This image confirmed that black holes are not theoretical. They are real structures that warp spacetime itself. And it validated general relativity and proved Einstein right once again. This is the oldest light in the universe. The cosmic microwave background is radiation left over from the Big Bang. It was released 380,000 years after the universe began, when space finally cooled enough for atoms to form. Oh! Before that moment, the universe was opaque. Light could not travel freely. When atoms formed, light was released. That light has been traveling through space ever since, stretched by cosmic expansion into microwaves. Satellites like COB, WMAP, and Planck mapped this radiation across the entire sky. The variations in temperature are tiny, only millionths of a degree, but those variations are crucial. They are quantum fluctuations from the first moments of existence. Gravity amplified them. They became the seeds of galaxies and galaxy clusters. This map is the baby picture of the universe. It shows the blueprint of all cosmic structure. It proves the Big Bang happened and gives us precise measurements of the universe's age, composition, and fate. December 7th, 1972. The crew of Apollo 17 was traveling toward the moon. They looked back and captured this. Earth fully illuminated. Africa and the Antarctic ice sheet visible. Cyclones swirling over oceans. The photograph became one of the most reproduced images in history. It gave humanity a full portrait of home. Unlike Earthrise, which showed Earth as distant and small, the blue marble presented Earth as dominant and detailed. You could see weather systems, ecosystems, and geology. The image arrived during the environmental movement of the 1970s. It became a symbol for Earth Day and conservation efforts. It showed that Earth is finite and interconnected. Deserts and rainforests, oceans and ice caps, all part of one system. This photograph reinforced the idea that we share one planet. It has no backup. It is beautiful, complex, and vulnerable. The blue marble became shorthand for planetary awareness and ecological responsibility. Jupiter's Great Red Spot is a storm that has raged for at least 400 years. It was first observed through telescopes in the 1600s. The storm is larger than Earth. Winds inside reach 400 miles per hour. It rotates counterclockwise, completing one rotation every 6 days. The red color comes from complex chemistry. Ammonia, methane, and other compounds react under ultraviolet light, producing chromophores that absorb blue light. Scientists still debate the exact mechanisms. The storm is shrinking. A century ago, it could fit 3 Earths inside. Now it fits only 1. No one knows why it is contracting or when it will disappear. The Great Red Spot is a reminder that planets have weather systems beyond our comprehension. On Earth, hurricanes last days. On Jupiter, storms persist for centuries. The scale and longevity challenge our understanding of atmospheric dynamics and planetary science. Saturn's rings are the most beautiful structure in the solar system. They span 280,000 kilometers, but are only 10 meters thick in most places. They are made of billions of chunks of water ice mixed with rock. Particles range from dust grains to house-sized boulders. The rings are not solid. There are thousands of individual ringlets, each orbiting at its own speed. Gaps between rings are carved by the gravity of Saturn's moons. The Cassini spacecraft spent 13 years studying Saturn. It captured images of the rings in stunning detail. It revealed features like spokes, waves, and ripples caused by gravitational interactions. The rings are not permanent. They are being pulled into Saturn by gravity and magnetic forces. In 100 million years, they may be gone. Right now, they're a transient masterpiece, a cosmic accident of beauty in physics that we are lucky to witness. Saturn's North Pole hides a mystery, a massive hexagon. Each side spans 30,000 kilometers. The hexagon is a jet stream, a river of wind flowing at 320 kilometers per hour. It was discovered by Voyager in the 1980s and studied extensively by Cassini. The shape is nearly perfect. It has persisted for decades without changing. Scientists have recreated hexagonal flows in laboratory experiments. They occur when fluids with different rotation speeds interact. But the exact mechanism on Saturn remains debated. At the center of the hexagon sits a hurricane-like vortex with an eye 50 times larger than Earth's hurricanes. The hexagon is proof that nature follows mathematical rules. Geometry emerges from chaos. Physics creates order. This structure exists nowhere else in the solar system. It is unique to Saturn, a planetary phenomenon that reminds us how much we still do not understand about atmospheric dynamics and fluid mechanics. Olympus Mons is the largest volcano in the solar system. It rises 21 kilometers above the Martian surface. Mount Everest would barely reach its midpoint. The volcano's base covers an area the size of Arizona. Its summit has a caldera complex 80 kilometers wide, formed by multiple collapse events. Olympus Mons is a shield volcano, built from countless lava flows over billions of years. Mars lacks plate tectonics, so volcanic hotspots remain stationary. Magma keeps erupting in the same location, building higher and higher. On Earth, tectonic plates move volcanoes away from their hotspots, creating chains like Hawaii. Olympus Mons is likely extinct. The last eruptions may have occurred 20 million years ago. The volcano is so massive that if you stood at its base, you could not see the summit. Curvature and atmospheric haze would hide it. This mountain is a monument to planetary geology, operating on scales we can barely comprehend. The first Martian sunset was photographed by Viking 1 in 1976. Later rovers captured the view in stunning clarity. The sun appears smaller from Mars because the planet is farther from the sun. The sunset itself is blue. This surprised scientists. On Earth, sunsets are red because our atmosphere scatters blue light away. On Mars, fine dust particles in the thin atmosphere scatter red light, letting blue wavelengths pass through. The result is a blue glow around the sun as it sets, fading to butterscotch and pink higher in the sky. The effect is haunting and beautiful. It reminds us that familiar phenomena operate differently on other worlds. A sunset is not universal. It depends on atmospheric chemistry, particle size, and pressure. This simple image captures the alien nature of Mars. It is a world where even the sunset defies expectation. It is a reminder that exploration reveals the unfamiliar hiding in the familiar. July 14th, 2015. New Horizons flew past Pluto after a 9-year journey. The images it sent back stunned the world. Pluto was not a dead, cratered ball. It was geologically active and complex. The most striking feature was the heart. Tombaugh Regio, named after Pluto's discoverer. The left lobe, Sputnik Planitia, is a plain of nitrogen ice. It has no craters, meaning it is young, possibly only a few million years old. Convection currents churn beneath the surface, resurfacing the ice. Mountains made of water ice, harder than steel at those temperatures, border the plain. The heart may have formed from an ancient impact that created a basin. Nitrogen accumulated there, creating feedback loops that maintain the feature. Pluto also has a tenuous atmosphere that freezes and falls as snow when the dwarf planet moves farther from the sun. This image transformed Pluto from a distant speck into a world with weather, geology, and dynamic processes we are still trying to understand. March 1st, 1982. The Soviet Union's Venera 13 lander touched down on Venus. It survived 127 minutes before succumbing to heat and pressure. The surface temperature was 464 degrees Celsius, hot enough to melt lead. Atmospheric pressure was 89 times Earth's, equivalent to being 900 meters underwater. The lander captured the first color images of the Venetian surface. Flat rocks and granular soil stretched toward a hazy horizon. The sky glowed orange from thick clouds of sulfuric acid. Venus is Earth's twin in size, but it evolved into hell. A runaway greenhouse effect boiled the oceans away billions of years ago. Carbon dioxide trapped heat. Surface conditions became incompatible with life. The Soviet Union sent multiple Venera landers. Most were crushed or melted within an hour. These images are monuments to engineering and determination. They show a world that could have been like Earth but took a different path. Venus is a warning of what happens when climate feedback loops spiral out of control. During a total solar eclipse, the moon blocks the sun's disk. For a few minutes, the sun's corona becomes visible. The corona is the sun's outer atmosphere. It extends millions of kilometers into space. It is hotter than the surface, reaching temperatures over 1,000,000 degrees. Scientists still debate why the corona is so hot. The corona is shaped by the sun's magnetic field. Plasma follows magnetic field lines, creating streamers and loops. Coronal mass ejections, violent eruptions of plasma, originate here. These can disrupt satellites and power grids on Earth. Ancient cultures feared eclipses. They saw the sun being devoured. Today, scientists chase eclipses to study the corona. They use specialized cameras to capture its structure. The images reveal dynamic activity, magnetic reconnection, and waves propagating through plasma. The corona is not a static halo. It is turbulent, violent, and constantly changing. Eclipses give us rare windows into solar physics we cannot study any other way. In 1054 AD, Chinese and Arab astronomers recorded a new star. It appeared suddenly and shone brightly enough to be visible during the day for 23 days. The star then faded. What they witnessed was a supernova, the violent death of a massive star. Today, we see the aftermath. The Crab Nebula is the expanding debris cloud from that explosion. Gas is rushing outward at 1,500 kilometers per second. The nebula spans 11 light-years across and is still growing. At its center is a pulsar, a neutron star rotating 30 times per second. The pulsar powers the nebula with high-energy particles and magnetic fields. The gas glows red from hydrogen, blue from oxygen, and white from mixed elements. The Crab Nebula is a laboratory for extreme physics. Neutron stars are the densest objects in the universe besides black holes. A teaspoon of neutron star material weighs 1 billion tons. This nebula is proof that stars die violently and that their deaths seed the universe with heavy elements, the raw materials for planets and life. The Sombrero Galaxy sits 28 million light-years away in the constellation Virgo. It is a spiral galaxy seen edge-on. The view is striking. A bright bulge of stars dominates the center. A dark dust lane cuts across the disk, giving the galaxy its sombrero-like appearance. The dust is the raw material for star formation. The galaxy contains 2,000 globular clusters, 10 times more than the Milky Way. These ancient clusters orbit the galaxy like swarms of bees. The sombrero has a supermassive black hole at its center, with a mass of 1 billion suns. The galaxy is classified as an unbarred spiral, though its dust lane and bulge make it appear almost like an elliptical galaxy from our viewing angle. Hubble captured this image in stunning clarity. It revealed individual star clusters and fine structure in the dust lane. The Sombrero Galaxy is a reminder that galaxies have architecture. They are not random collections of stars, but organized systems shaped by gravity, rotation, and billions of years of evolution. Stephan's quintet is a group of 5 galaxies locked in gravitational combat. They sit 290 million light-years away in the constellation Pegasus. 4 of the galaxies are actually interacting. The 5th is a foreground object, not part of the group. The James Webb Space Telescope captured this system in unprecedented detail. It showed shock waves from colliding gas, triggering massive bursts of star formation. Tidal forces stretch and distort the galaxies. Stars are being ripped from their home galaxies and scattered into intergalactic space. One galaxy is plowing through the group at 800 kilometers per second, creating a bow shock like a boat through water. Galaxy collisions are slow-motion disasters that unfold over hundreds of millions of years. Stars rarely collide because galaxies are mostly empty space, but gas clouds collide, compress, and ignite new generations of stars. Stephan's quintet is a preview of the Milky Way's future. In 4 billion years, our galaxy will collide with Andromeda. This image shows what that merger might look like. Eta Carinea is a ticking time bomb. It is one of the most massive and luminous stars in the galaxy. It is a binary system, 2 massive stars orbiting each other. The primary star has at least 100 times the Sun's mass. In the 1840s, Eta Carinea erupted. It became the second brightest star in the sky for several years. The eruption ejected 10 to 40 solar masses of material. That gas now forms the Homunculus Nebula, 2 lobes expanding outward. The star survived, but it is unstable. It could explode as a supernova at any time. It might have already exploded. The star is 7,500 light-years away. We see it as it was 7,500 years ago. The supernova might be visible from Earth within our lifetime, or it might take thousands of years. When it explodes, it will briefly outshine the full moon. Eta Carinea is a laboratory for studying massive star evolution. These stars live fast and die violently. They forge heavy elements and enrich galaxies with the building blocks of planets and life. The Boomerang Nebula is the coldest place in the known universe. Its temperature is 1 degree Kelvin, colder than the cosmic microwave background radiation itself. The nebula formed from a dying star. The star ejected its outer layers in a fast wind. That wind expands so rapidly that it cools by adiabatic expansion. The gas cools faster than it can absorb heat from the cosmic microwave background. The result is a nebula, colder than the ambient temperature of space. The shape is bipolar, like an hourglass. This structure suggests a binary companion star, or a strong magnetic field, shaped the outflow. The nebula is 5,000 light-years away. It is in a brief evolutionary stage. In a few thousand years, radiation from the central star will heat the gas. The nebula will warm. It will become a planetary nebula, glowing in visible light. For now, the Boomerang Nebula is a frigid ghost, a reminder that the universe contains extremes we can barely imagine. 40 light-years away sits a small red star, TRAPPIST-1. Circling that star are 7 planets, all roughly Earth-sized. 3 orbit in the habitable zone, where liquid water could exist. The system was discovered in 2017 using transit photometry. As planets pass in front of their star, they block a tiny fraction of light. By measuring these dips, astronomers calculated the planets' sizes and orbits. The TRAPPIST-1 system is compact. All 7 planets orbit closer to their star than Mercury orbits the Sun. But the star is small and cool, a red dwarf with 8% of the Sun's mass. The planets receive similar amounts of radiation as Earth, Venus, and Mars. The planets might be tidally locked, with one side always facing the star. This creates permanent day and night hemispheres. The planets likely have atmospheres. The James Webb Space Telescope is studying them for signs of water, oxygen, or methane. TRAPPIST-1 proves that Earth-sized worlds are common. It gives us hope that life might exist beyond our solar system. May 12, 2022. Scientists revealed the image of Sagittarius A, the supermassive black hole at the center of our galaxy. It weighs 4 million suns. It sits 27,000 light-years away. The image required 3 years of data processing. The black hole's accretion disk is turbulent. Matter orbits in minutes, changing the image faster than telescopes can capture it. Researchers combined multiple observations to create an average view. The ring is asymmetric. One side appears brighter due to relativistic beaming, the same effect seen in M87*. Sagittarius A star is relatively quiet for a supermassive black hole. It consumes very little matter. Most material is blown away by magnetic fields and radiation. But occasionally it flares, briefly becoming 100 times brighter. The black hole is the anchor of our galaxy. Stars orbit it at thousands of kilometers per second. By tracking these orbits, astronomers confirmed the black hole's mass and proved that general relativity accurately describes gravity near event horizons. This image shows the monster at the heart of our cosmic home. In 1977, NASA launched Voyager 1 and Voyager 2. Each carried a golden record. The records contained sounds and images from Earth, music from different cultures, greetings in 55 languages, natural sounds like thunder, birds, and whales. The records are time capsules. They are messages to any intelligent life that might find them. The chance of discovery is vanishingly small. The Voyagers are now in interstellar space, but it will take 40,000 years to reach even the nearest stars. The records are more for us than for aliens. They force us to ask what defines humanity. What would we want another civilization to know about us? Carl Sagan led the project. He and his team debated what to include. They chose diversity. Music from Bach and Beethoven, but also from India, Zaire, and Peru. The records are sealed in protective covers, with instructions for playback etched on the surface. They include a pulsar map showing Earth's location. The golden record is a message of hope. It says we were here, we existed, we reached out. July 20th, 1969. Neil Armstrong stepped onto the moon. His footprint would last millions of years. The moon has no atmosphere. No wind erodes the surface. No rain washes it away. Micrometeorite impacts will eventually disturb the print, but for now it remains, a human mark on another world. This photograph is proof. It shows we left Earth. We walked on another celestial body. The moon's surface is covered in regolith, fine dust created by billions of years of meteorite impacts. The dust is abrasive, and clings to everything. Astronauts describe it as smelling like gunpowder. The footprint photograph became an icon. It represents exploration, courage, and the drive to push beyond boundaries. It shows that humans can achieve what seems impossible. The footprint is also humbling. It is a tiny mark on a lifeless world, insignificant in cosmic terms. Yet for us, it is monumental. It is evidence that our species can transcend its origins and touch the cosmos. The footprint will outlast civilizations. It is our most permanent monument. July 12, 2022. The James Webb Space Telescope released its first deep field image. The image covered a patch of sky the size of a grain of sand at arm's length. It revealed thousands of galaxies. Webb used infrared vision to see farther back in time than Hubble. It captured light from galaxies that formed only a few 100 million years after the Big Bang. These galaxies appear red because their light has been stretched by 13 billion years of cosmic expansion. Webb also revealed fine structure, spiral arms, star-forming regions glowing blue, dust lanes. Gravitational lensing from massive foreground clusters magnified and distorted distant galaxies, creating arcs and multiple images. The deep field proved Webb's capabilities. It showed that the early universe was more complex than expected. Massive galaxies formed earlier than models predicted. Webb is rewriting our understanding of cosmic history. It is finding galaxies, stars, and planetary systems that challenge existing theories. This image is the beginning of a new era in astronomy. We are seeing the universe as never before. The frontier has moved. These 25 images are not decorations. They are primary sources. They changed science, philosophy, and culture. They gave us perspective. They showed us where we are in the cosmos and how fragile our existence is. They revealed violence and beauty operating at scales beyond human comprehension. They proved theories and demolished assumptions. Each image represents years of engineering, planning, and human effort. They forced us to think differently about ourselves. We are not the center. We are participants in a universe that is ancient, vast, and largely indifferent to our existence. Yet that same universe gave rise to us. We are made of star material. We are the universe becoming conscious of itself. These images are our inheritance and our responsibility. They show what we have learned and how much remains unknown. They are invitations to keep looking, keep questioning, and keep exploring. The next 25 images are waiting to be captured.